All right, so today we're going to specifically talk about arithmetic and geometric series versus just series in general. So we want to figure out, what is this sum? Like, what would it be, kind of thing. Because it seems like really annoying to add up all the numbers from 1 to 100. But before we talk about it, a story. So Carl Gauss was a student somewhere in elementary school-ish age, and his class was being super annoying. So his teacher was like, I have a great idea. This is a way to shut them up. They'll be quiet. I'll be working on this for ages. I can get some other stuff done. So he told them to sit down and add all the numbers up from 1 to 100. Like 30 seconds later, Carl got up, showed his teacher his chalkboard, and he had the answer. And the teacher was shocked and was like, how on earth did you do this? So at home, go through these questions to figure out how he got the answer so quickly. Okay, so if you write out all the numbers 1 to 100, and then you're at 100 to 1, you can notice these columns are all going to add up to 101. So then if we sum all of those numbers together, we have 100 101s, so you end up getting 1,000 and 100. And then to get our sum of 1 to 100, you can divide by 2 to get 50, 50. The reason being, we listed all of our numbers twice here. So half of this is going to be your sum. So that is the sum to this. So that leads us into the formula for the sum of a finite geometric sequence. So here, if we have a series, we have a sequence that ends, so it like stops after 10 terms or something. This is the formula. So n is your number of terms. So 10 terms, 5 terms, 100 terms, whatever it is. You put your first term right here and your last term right there. And then this 2 always stay the same. That's the average of each of your terms. So if we do an example here, I'll write the formula here. You're going to have number of terms times the first term plus the last term, all divided by 2. So first term, plug in 1, and we'll end up getting 10. Your number of terms are going 1 to 200, so you have 200 terms. Last term, plug in 200, so 10 times 200, and then divide everything by 2. And if you type this into a calculator, you should get 201,000 as your answer. So much easier than adding like 10 plus 20 plus 30 plus 40, etc., 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 all the way up to 200. All right, so here's this one. Do the same idea and then confirm it just by adding the numbers by themselves. So careful here, you have 5 to 8. This is going to give you a total of 4 terms because you have 5, 6, 7, 8. So only 4 terms, not 8. And then your first term, you want 2 times 5 minus 1, and then add on 2 times 8 minus 1, and divide everything by 2. This should give you 48 when you simplify it. And then if you want to check by adding the individual terms, you do 9 plus 11 plus 13 plus 15, which will still equal 48. Okay, so there's a sum for arithmetic series. Is there a sum for geometric series? The answer is yes. So how they figured it out, this you can follow along. You won't need to be able to do this on your own, but follow the process. Let S of n represent the sum of a geometric sequence. So your first term all the way up to your last term. Then we'll multiply both sides of this by r, and you end up getting this. So your first term now has an r in it. Your last term, you get rid of the -1 because we added one more r. So take these two and subtract them. This a sub r is going to cancel with this one will cancel with this one, and this one will cancel with the one that was right there, all the way up to this one canceling with this one. So then at the end, you have this left over and this left over that didn't cancel out. So that's where these come from. So then multiply both, or factor out this s sub n to get 1 minus r. And then you can divide by 1 minus r, and we get this formula. And that is then going to be your formula for a geometric series. So to find the sum of a geometric sequence, or what is the sum of a geometric series, this is what it's going to look like. So a is still your first term, 1 stays, 1 stays, r is then your common ratio, and n is still the number of terms. So that's it. Your assignment is on Schoology. Let me know if you have questions.